Hello Year 10. Today we are talking about exponential functions and their graphs. Before we do that, let's revise how to solve an exponential equation. So we know it's an exponential equation because of the powers of x that are in these equations. Okay, to solve it, we want to make the bases the same, and in question A, the base of our exponential is the 3. So if I can make 9 a base of 3, which I can, 9 is 3 squared, then that means that if the bases are equal, then the powers must also be equal, which means that x is equal to 2. Doing that again for part B. My exponential has a base of 5. So I would like to try to make 125 a base of 5, which I can, because 125 is the same as 5 cubed. Now, I can't get rid of my bases while this right-hand side here is still in fraction form. So my next step is that I have to bring the 5 to the power of 3 up, which will give it a negative power of 3. Once I have my base of 5 on the left, my base of 5 on the right, that means that the power must be equal, which means x is equal to negative 3. In part C, we have a base of 2 and we have a base of 4. Okay, we never want to make bases bigger, so let's see if we can make them both a base of 2. So that means we will leave the 2 to the power of x plus 2. But 4 is the same as 2 squared. The squared of that will multiply with the x that was already there. Now that they are both bases of 2, we get rid of the bases and we say that x plus 2 is equal to 2x. Then I will subtract the x away, which means that x is equal to 2. Okay, so on to the functions and graphs of exponentials. So the equation of an exponential will always be in the form y is equal to a to the power of x. That is because the x is the exponent or the index or the power. And that's what makes it an exponential function or an exponential graph. The basic shape, your starting shape of an exponential is this one. On the left-hand side of the graph, it starts really, really small, close to the x-axis, but just above it. It doesn't ever touch it. And then it gradually increases to 1. And then after 1, that y-intercept, it will start to increase very, very quickly, exponentially even. On the next page, it says, let's look at a series of exponential graphs and get a sense of how they can be sketched quickly. So we have 4 of them here. So this is a giant table of values that we're going to fill in and then plot them all on the graph below. So the first equation is y to the power of 2x. So starting with x is equal to negative 3, we want to put in 2 to the power of negative 3, which is equal to 0.125. Then x to the power of negative 2 is 0.25. Then x to the power of negative 1 is 0.5. Then to the power of 0 is 1. To the power of 1 is 2. To the power of 2, you probably don't need the calculator for these, but thought at least for the first one I would do it. 2 to the power of 2 is 4. And then for the last one, we want to the power of 3, which is 8. Okay, so just typing those into the calculator. I'm going to keep going and fill the rest of them in. The next one is y equals negative 2 to the x. What happens when we put that minus sign in? If we go back to the very first value, which was x is minus 3, we have minus 2 to the power of negative 3. So what happens is I end up with the same number, but it now makes them all negative. So it's negative 0.125, negative 0.25, negative 0.5, -1, -2, -4, -8. Okay, the next one. What happens when I put the minus in the power? Let's try and see if we can figure out a pattern here. If we do 2 to the power of minus from the formula, and -3 is the number that we want to put in. Now, technically, those two minuses will make a plus, which means that 2 to the power of 3 is 8. So what's happening, if we compare it to the first line up here, by putting the minus in there, I am reversing the chart. So I'm starting with the 8 over here on the right, and then the next one will be 4, then 2, then 1, then 0.5, 0.25, and 0.125. You could obviously put all of those in your calculator again if you wanted to. Okay, so put the minus in some different places, and we've seen what that has done. What happens if we change the base? So all of those ones have been bases of 2, but the last one is a base of 5. So let's do a few values here. We want 5 to the power of -3. That's 0.008. It's going to be very small and hard to put on a graph. Then we want to the power of -2, which is 0.04. Then we want to the power of -1, which is 0.2. Then we want to the power of 0. Anything to the power of 0 is 1. 5 to the power of 1 is 5. 5 to the power of 2 is 25. And 5 to the power of 3 is 125. Okay, the table is filled in. Let's shrink it down a bit so that we can now plot those on our graph. So first one, when x was -3, we have a very small value of 0.125. Then we have 0.25, 0.5, and then 1, okay, because I'm going up by each of my grid marks is 2, 1 is only half that space there. Then at 1 it's 2, 2 we go up to 4, and 3 we go up to 8. So it's starting to increase quite rapidly there. So start small, goes through the 1, and then increasing. Okay, so that is y equals 2 to the power of x. Okay, moving on to the second row of our table. Our first value at -3 is -0.125, which is below. And so it's basically symmetrically reflected over that x-axis from the last one. So let's join that up like that. Make sure that it always looks like it's getting closer and closer to that x-axis on the left side there, but never touches. So that is y to the power of, y equals -2 to the power of x. Then the third row, we're going to do 2 to the -x. So at -3, we are at 8. Then at -2, we're at 4. Then 2. Then 1, then a half, oops, that wasn't a half, so let's try that again, then 0.25, and 0.125. So it's coming down instead. So they're all having that shape, it's just different ways that I'm reflecting it around the Cartesian plane. So that is y equals 2 to the -x. So let's have a little chat about all those three to start with. So the green one is my base equation when it's 2 to the power of x. Putting a negative in front of it creates the blue graph, which gets reflected over the x-axis. Putting a negative in front of the power reflects to get the red graph, which is reflected over the y-axis. And the last graph, y equals 5 to the power of x, is just going to be made steeper than the green graph. So it starts smaller on the left-hand side of the y-axis. So 0.008 is tiny, tiny, tiny. And then 0.4, 0.2, very, very small values there. But then it hits the 1 like all of the others. When we get to x equals 1, we are at 5. 2 is 25, which is way off the top of my graph. So it's going to start really, really small here, meet at the 1 like the other graphs, and then go super, super steep like that. So that is y equals 5 to the power of x. Now the other thing you'll notice that no matter what I did to those graphs, none of them went through the x-axis. They all kind of got really, really close to it at some point, but never touch it. Now there is a special name for a line that a graph approaches and never touches. It is called an asymptote. So to draw an asymptote on there to indicate that you know what that is, you draw a dotted line on the axis, so dot, 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 across the x-axis there. Put some arrows on the end, and we put HA, which stands for horizontal asymptote, and the equation of that asymptote is y equals 0. So all exponential graphs has an asymptote. It is possible to move it, but we're not doing that in our exercise today. We are just keeping that asymptote on the x-axis, so it will always be at y equals 0. Okay, moving on to question number 2. Sketch the graph of the following on the same set of axes, labeling the y-intercept and the point where x equals 1. So we want to do this without a table. So let's give this a go. We're going to draw straight to one big Cartesian plane here, where I'm going to put all 3 graphs on it. Now, because these all are positive, there's no minus signs in any of this, these are all going to be sitting above the x-axis. So I'm going to be keeping my x-axis nice and low down here, so that I have some room to draw it above the axis there. So I'm going to label a few values, 1, 2, 3, 4, that's probably enough. Put an extra one, and then let's go 1, 2, -1, -2. Probably don't even need those, that's probably way more than I actually need. So if I want to draw y equals 2 to the x, first of all, you always want to know the y-intercept of a graph. And so that's when x equals 0. And for all of these, if you do 2 to the power of 0, or 3 to the power of 0, or 4 to the power of 0, it is always going to be equal to 1. So the y-intercept is 1. Now we know that it's going to start nice and shallow down here, and it's going to get very, very steep. We always want to show one extra point, and the question asked me to show what was happening when x is equal to 1. So if I sub x equals 1 into my equation, I get 2 to the power of 1, which is 2. So when x is 1, y is 2, there's my other point, and then I'm going to do a sketch, just using the 2 points and knowing the shape to draw the rest of it like that. Label that point that I've been given, so this is the point 1, 2. Then moving on to the next one, 3 to the power of x. It's going to have the same y-intercept, because 3 to the power of 0 is still still 1. Anything to the power of 0 is 1. When I sub x equals 1 in, 3 to the power of 1 is 3. So it'll have the same shape, but it will be slightly below the purple line on the left side, but then steeper on the right-hand side. So that is the point 1, 3, and I should also write the equation on here. This is y equals 3 to the x. This one was y equals 2 to the x. The final one, y equals x to the power of 4. It is going to have, yet again, the same y-intercept, which is 1. Then when I sub in x equals 1, 4 to the power of 1 is 4. So as I make the number that is the base, as I make that bigger, it makes the graph steeper on the right-hand side, but shallower on the left-hand side. So that is y to the power of 4x. That point is the point 1, 4. The other thing I would like you to remember to include is your horizontal asymptote. So we're going to draw our dotted line. on the x-axis, that is a horizontal asymptote, and it is at y equals 0. Question 3. Find the intersection of the graph y equals 2 to the x, so that's an exponential equation, and y equals 8, that is a straight line. To be more specific, it's a horizontal straight line. And it says by sketching accurately. So using the space provided here, let's draw up a nice big graph. Y equals 2 to the x is again all positive, so I'm drawing my x-axis nice and low. And I know that I need to get to y equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's where y equals 8. Okay, so let's start with the y equals 8 because that's the easier of the two. Y equals 8 is a horizontal line that goes through y equals 8. Then the y equals 2 to the power of x. We'll start with our y-intercept because 2 to the power of 0 is 1. Then we sub in x equals 1, 2 to the power of 1 would be 2. And what we want to do is we know this exponential is going to be coming up and it's going to keep going up. I want to know where it's going to intersect with that other blue line that I've drawn there. So if I go to 2, 2 to the power of 2 is 4, still not big enough. If I go to 3, 2 to the power of 3 is 8. So that's when it will hit the line. So by drawing my somewhat accurate graph, I know that this point of intersection, which I'm going to go POI, which stands for point of intersection, is the point 3, 8. Okay, so that's it. You can now do exercise 3F, and there is also a progress quiz on page 213 that you can do as well.